Hello, welcome to this video. So this problem, will be about a conventional problem, in DSE 2021. So about remainder theorem. So part A, so find C. But of course, we need to look at the question first. Part A. So the polynomial is divisible by x minus 5. So we are already given the factor, of px. But mainly, we will try to use the later sentence. So, because, for this sentence, the information, are quite sufficient, quite enough information, seems to be given here. So, of course, you can make use of the long division, to help you visualize the problem. So when px is divided by x squared plus x plus 1, the corresponding quotient will be 2x squared minus 37, and then the remainder will be cx plus c minus 1. Now of course, for part A, so we need to express px in terms of x squared plus x plus 1, and then 2x squared minus 37, and then finally the remainder, so cx plus c minus 1. So so here 1 mark already, because we try to make use of the division algorithm to relate the 4 polynomials here. We try to relate px, we try to relate x squared plus x plus 1, we try to relate the quotient as well as the remainder polynomial, the 4 polynomials all together. So 1 precious mark already. So very important, to set up the expression first. And then since px is divisible by x minus 5, of course here, we can make use of p5 then. And then p5, of course, you need to put a 0 here, otherwise the mark will not be given to you. And then 5 squared plus 5 plus 1, is 31, am I correct? Oh yeah. And then times 13. And then plus 6c, right? Plus 6c minus 1. And then finally, so c, after solving out, so c will be negative 67. So that will be the stuff for part A. And then for part B, so c equals to negative 67. And then for part B, so just 1 mark. So of course, so here we try to make use of the result we obtained in part A. So px equals x squared plus x plus 1 times times 2x squared minus 37. And then since c equals to negative 67, so that's why minus 67x, and then minus 67 minus 1. So that will be minus 68, right? So and then after that already you can put negative 3. To test whether x plus 3 is a factor. Try to check it out. Now here, we cannot directly write down 0. Otherwise, well, it seems that, we have not done any checkings, right? So that's why, so 9 minus 3, so 6, and 6 plus 1, so 7 times negative 19, and then plus 201, minus 68. Oh, really, it's equals to 0. So it's double checking, it's also double checking the answer from part A as well. So that's why at the end, we can conclude x plus 3 is a factor of px. Okay, so and then we can get the only mark for part B. And then for part C, so part C, someone claims that, okay, all the roots of the equation px equals 0 are all real numbers, right? So that's why we are curious, okay, in the equation px equals 0. And then a px, okay, from part A, okay, so that would be x squared plus x plus 1 times 2x squared minus 37 minus 67x, and then minus 60x equals 0. And then here we try to expand it. Okay, so actually, okay, the expansion, okay, is quite tedious, okay, for the okay, for the first term, right? So that's why here we try to expand it out. So 2x to the power 4, and then for the x cubed term, okay, so basically just 2x squared times x, so that's why plus 2x cubed. Okay, and then for the x squared term, so 2x squared times 1, so that will be 2x squared, and then minus 37x squared, so that would be minus 35x squared. And then for the x terms, okay, so that will be only negative 37 times x, so that will be negative 37x minus 67x, so that will be negative or minus 1 over, minus 1 over x, and then minus 105 equals 0. Okay, because negative 37 minus 68 will equals to negative 105. And then, well, that would be super important, okay, to use the result from part B. Okay, so that's why here x plus 3 must be a factor. Okay, must be a factor. So here, okay, we'll try our best, okay, to obtain the corresponding cubic quotient. Okay, so that will be 2x cubed, and then minus 4x squared, okay, and then minus 23x, and then minus 35 equals to 0. You can do this, okay, by long division or by comparing coefficients. Okay, so and then this is x plus 3, and then still, okay, we have a cubic polynomial needed to be decomposed, or you may say factorized. And if you try to look at the very first beginning, so actually x minus 5, okay, will be another factor, so don't forget that. So and then using this, okay, so let me demonstrate how to use the comparing coefficients to handle, right? So 2x squared, why? Because from the above, okay, it's 2x cubed, so 2x cubed can only be multiplied by x times the x squared term, so that's why the remaining quotient, the leading term, must be 2x squared. And then minus 5 times what will equals to minus 37, minus negative 5 times what will equals to negative 35 there, so of course plus 7. Okay, and then the rest, okay, so the x term, okay, so that will be plus x, okay, plus 6x. Why? Because, okay, 6x times negative 5 becomes negative 30x, plus 7x will become negative 23x. Okay, so here we try to use the comparing coefficients to obtain it. Okay, so and then here, okay, of course, okay, so negative 3 and 5, okay, the first two roots, okay, will be real. But of course, okay, here we need to look at the last equation, the last quadratic equation. So for the equation 2x squared plus 6x plus 7 equals 0. So after using formula O1, so math error. So we'll try to formally write discriminant b squared minus 4ac. And you can see this is negative 20, which is less than 0. Okay, so that's why just follow the set procedure. So because delta less than 0, so that's why the equation 2x squared plus 6x plus 7 equals to 0 does not have real roots. Okay, so that's why some of the roots, okay, are not real. Okay, that means not all the roots of the equation px equals 0 are real numbers. Okay, so that's why you can see the claim is incorrect. So finishing this part, and then the whole problem is done. Thank you for watching.